In the previous video, we reviewed Swift's collection types by discussing arrays, dictionaries, and sets. In this video, we're going to take a look at classes, structs, and enums, and open a dialog in regards to reference types and value types that will be ongoing throughout this course. Later in this video, we'll take a quick look at Swift's powerful enum type. In Swift, we can choose from 3 different options to store our structured data: structs, classes, and enums. If we look at Swift's standard library, we'll notice that roughly 90% of the public types are defined as structs, with classes and enums making up the rest. Not only does this demonstrate a preferred language convention, but it serves as a strong indicator of the importance of structs in Swift. It's important to note that classes are reference types, while both structs and enums are value types. Again, we'll be continuing this reference type and value type dialog throughout this course, but for now, we'll demonstrate how this works. We'll start by creating 2 variables, one for a first name and one for a last name. Next, we'll assign our first name with the value of John, and we'll initialize our last name variable to our first name variable's value. Of course, the value of John gets copied into our last name variable, which we can overwrite with a simple assignment operator. Now let's take this example a step further. If we declared a function that reassigns a given value accordingly, and then passed our value first name into our function, one might be inclined to expect our function to change the value of our first name's variable, though by default it doesn't. Instead, we're greeted with an error message. When we pass values into a function, a copy is made. This is exactly how we should think of structs. Of course, there are ways to change this default functionality. One way is by letting Xcode fix the problem by adding the keyword var to make the value mutable. Another way is by utilizing the in-out keyword, like so. Here we have the same example as before, applied to a struct named person. Person has 2 values in it, a first name, which is initialized to Steve, and a last name, which is initialized to Jobs. So our first variable, person1, contains the values Steve and Jobs. When I assign person1 as a value of person2, I'm doing the exact same thing I did in the previous example. So what person2 is going to point at is a shallow copy of the person object that person1 points at. So with our examples being similar, if we pass our person1 object into a function, again a copy is made. In other words, person1 still has the values of first name Steve and last name Jobs. Now let's see how a class handles this exact same scenario. We'll replace our struct with a class and instantiate our person1 and person2 objects, giving them both the value of first name Steve and last name Jobs. However, this time when we assign our person2 with a new first name, both person1 and person2 receive the new name of Jane. We'll notice the same thing when passing our person object into the same renaming function as before. This time, if we print out the value of person1.firstname, we'll get the value of Pat. So, thinking for a moment, what do we suppose the value of person2.firstname is? If we print out the value of person2, we'll see we get Pat. So that's the crucial difference between structs and classes. Hopefully, this begins to answer the question as to why the Swift standard library is composed largely of structs. Having said that, classes and structs are actually very similar, both having properties, functions, and initializers. So this begs the question, when should I use a class over a struct? We're going to do some performance measurements later in this course, which will make the answer apparent, but a good rule of thumb is, whenever our intended object has values that will change, use a class. Otherwise, use a struct. Before we move on, let's take a look at Swift's enum, which is another value type. Enums, in general programming, are structures that allow us to assign meaningful names to a set of integer values. Enums in Swift, however, are first-class types, much more flexible than in most other languages. Of course, we can use an enum in much the same way we do in C. In this example, the compiler assigns an implicit raw value to each case, of 0, 1, 2, and 3. Though if we would have started north with a value of 250, for instance, our values would have incremented from that point, like this. Enums are considered algebraic data types in Swift, and can become fairly complex, utilizing initializers, functions, and more. Let's take a look at one more enum example before we move on. In this example, we'll create a simple state machine called employee state, which represents 4 possible states for an employee to be in: clocked in, lunch out, lunch in, and clocked out. Then we have a method called next, which is a mutating method. This means that it modifies the value of the enum by assigning to self. Since enums are immutable, using the mutating keyword is actually the only way to modify its values. The way this method works is that it treats our enums like a states machine by moving our enums into the next state each time we call next. Let's test out our enum by declaring a variable and giving the initial value of employeestate.clockedout. And finally, we'll call next to see our state machine in action. For further discussion on structs, classes, and enums, visit the resource page for this video. In this video, we looked at the differences between structs and classes. We also looked at Swift's unique enum type. In the next video, we'll review Swift's flow of control operators, patterns, and optionals.